So, at time t equals 0 seconds, the path of the water is furthest to the right. As the sprinkler rotates to the left, the path of the water passes the vertical target line at t equals 6 seconds. The path of the water is furthest to the left for the first time when the sprinkler rotates right. And the path of the water passes the vertical target line and is path of the water is furthest to the left for the first time. I read that wrong. Okay. As the sprinkler rotates to the left, the path of the water passes the vertical target line. At time t equals 6, the path of the water is furthest to the left for the first time. Then the sprinkler rotates right, and the path of the water passes the vertical target line and is furthest to the right again at time t equals 12. As the sprinkler rotates, the measure of the angle formed by the path of the water and the vertical target line periodically increases and decreases. The sinusoidal function h models the measure of the angle in radians formed by the path of the water and the vertical target line as a function of time t in seconds. A negative value of h of t indicates the path of the water is to the left of the vertical target line. A positive value of h indicates the path of the water is to the right of the vertical target line. So I am going to put negative 0.4 radians here because whenever we're to the left, we're going to measure that as a negative radian there. So we need to fit this to the curve that they have given us here. Okay. The first thing you always need to do on these problems is decide what you're starting at. Are you starting at a maximum, midline, or minimum? To do that, you need to look for where t equals 0. And right here, they say t equals 0. At time t equals 0, the path of the water is furthest to the right. And they told us that right is positive, right? So are we starting at a maximum, midline, or minimum? Maximum. And that's actually, I think, the easiest one to start at because that means our y-axis is right here and t equals 0 right here. And if we want to go ahead and put in that highest point, it's 1.2 radians. Okay, our lowest is negative 0.4 radians. What is our midline going to be? Or how would we find it? Add them together and divide by 2. So 1.2 plus negative 0.4 divided by 2, that is going to be 0.8 divided by 2, which will give us 0.4. So 0.4 here. So the x-axis, let me use different colors here. I'm going to use red for my y-axis. My x-axis is kind of like here, halfway between, right? That's my, and I guess it's technically not an x, it's a t and an h of t, right? So this really, I should put 0 right here. Okay, are we all okay here? Okay, so those are, we've got our y coordinates. So for these points, you could go ahead and fill in those y coordinates. So here you got 1.2 and 1.2. Down here, you've got negative 0.4, and then there at the midline, you've got 0.4 and 0.4. Okay, they tell us that we started at a maximum, so that's t equals 0 right there. At t equals, they tell us that t equals 6, we're furthest left. Is that maximum, midline, minimum? That's a minimum. So that's at 6. And then they tell us at 12, we're back over to the maximum point. Now, another way to do this, like, these numbers are a little easier on our x-coordinates, right? Because what number's halfway between 0 and 6? 3, right there. And halfway between 6 and 12 is 9, so you can probably do this a little bit more easily with these numbers because they're just nice, pretty whole numbers, right? But the other way we can think the period of this graph is 12, right? Because that's how long it takes us to go from maximum back to the next maximum. So sometimes it's a weird number. Sometimes it's like pi over 4 or 1/3 or something like that, right? So whatever your period is, if you divide it by 4, that equals your tick mark. So like in this case, 12 divided by 4 is 3, and you're just counting by 3s. 3, 6, 9, 12. But if it's harder numbers, you may need to actually like work that out. It might be, I know we had one that was like 9/4, and then you had 18/4, and then you had 27/4, right? So it was much harder to think about. Okay, everybody okay here? Got our points. All right. Now, they have asked us to write an equation, and we have to use sign. And they're making us use sign to make the problem harder, pretty much, because what could we use without shifting it any? Cosine. It would be better, right? And there's a chance they might give you cosine on this. So don't assume it has to be one that has to be shifted. But a lot of times they give us ones that need to be shifted. So some of these values are pretty easy to find. Okay? You got A, B, C, and D. D is just your midline. D is 0.4. A is your amplitude. What is our amplitude here? 0.8. Because if I do 1.2 minus 0.4, that gives me 0.8. Right there. For B and C, I've got to do a little more work. So the period of this graph is 12, right? That's how long it takes us to get from maximum to maximum. So 2 pi over B equals your period, or a lot of you guys go ahead and like just divide right there. So you got 12B equals 2 pi. You divide by 12. So B equals 2 pi over 12, which does reduce to pi over 6. So our B value is pi over 6. Okay, and then I think that finding the phase shift is probably the hardest if it has one. If it doesn't have one, it's easy. It's just 0. But if I'm doing sine instead of cosine here, sine starts at a midline. And then it goes to a maximum. And then it goes back to the midline. And then it goes to a minimum and back to the midline. So I'm going to draw in my little dotted graph here. This is what sine would look like if it had all the correct A, B, and D values, but no phase shift, no C. So I want to take my dotted line, I want to move it back to the solid line. So if I look at my tick marks, that's just one tick mark, it is 3, right? I want to go to the left, but to go to the left, what do I have to put? I got to put positive 3. So I'll have a positive 3 right here. You just put 3. Okay, here. All right. And then the last part is a pretty standard problem. There's like standard answers for this. So we are looking for, whenever you read this, first part H, the t coordinate of K is at T1 and the t coordinate of P is at T2. So the main thing you need is K to P. You need to know which points you're looking at. And we are talking about K to P. That's this part of the graph. Okay. is that part of the graph positive or negative? Positive, because it is above the x-axis. The x-axis runs right here. And then is that graph increasing or decreasing? Increasing. So positive and increasing is going to be our answer there. Okay, it's just straight asking you about the graph, right? Then, I have not fixed these problems where it gives you the more modern wording here. But it's going to say, instead of saying describe how the rate of change of H is changing, I believe it is going to say tell the concavity and describe if the rate of change is increasing or decreasing. Right, so here, there are only two answers. If our graph is concave up, our rate of change is increasing. If our graph is concave down, our rate of change is decreasing. Those are your only two options, right? On this graph, are we concave up or concave down? Down. Concave down here. So, we're going to say on T1 to T2, the graph of H is concave down, so the rate of change of H is decreasing on this interval. That's your answer for this part. The only two things that can change. If the graph is concave up, you're going to say concave up, and you're going to change decreasing to increasing. But if you just pretty much like know this is how you want your answer to look, it's just those two options. That's your only options for that part. Yeah, that's fine. If you kind of like switch the clauses there, that's fine too. Be careful. I have seen some of you say the interval is increasing, or the interval is decreasing, or the interval is concave up, or the interval is concave down. The interval does nothing. The interval tells you where to look, right? The graph, or the rate of change of the graph, is what is doing something, right? So whenever you're talking about interval, you want to always say like on this interval, right? So, and it would be okay to say like on this interval instead of on T1 to T2. That would be okay also. All right, so I feel like we got the most experience with these. Some of you did really well on that FRQ that we did for these on that test. Some of you struggled a little bit with those. This is a good chance to get some more practice if you were having some trouble with those. So particularly if you know these confused you, this would be a great day to come to